Alright. So good. Take a look here. Here was our equation of a circle that you should know, right? Let's go back and let's go all the way back and look at how we develop this, right? So head up circles. Head up circles. I'm gonna go over a couple of equations from straight lines for you to remember, right? Right? So if we have circles, before we do circles, let's take a look at a straight line, right? If I give you a straight line A, that's x1, y1, and B, x2, y2, right? There's a couple things you need to remember. You need to remember how to find the length AB. That's what? How to find the length of AB? Square root of x2 minus x1 squared plus y2 minus y1 squared. Right? You can also find the gradient. Right? I'm bothering to write. Did I write that? All right, anyway. Right? Y2 minus y1 over x2 minus x1. Remember, if you have parallel lines, the gradients are equal. If you have perpendicular lines, the product of the gradients is -1. Right? So the gradient equal here is the parallel, right? There's some small things to remember. Remember, the equation of a line is always of the form y is equal to mx plus c. Right? You can also use this version, y minus y1 is m by x minus x1. Right? So that's our next version for you to get the equation of a line. Okay? Right? So just some small things for you to remember. And last thing, if you were to solve two lines simultaneously, if you solve line 1 and line 2 simultaneously, you're going to find the point of intersection. That's okay? If you solve two lines simultaneously, that's what you'll get. Right? And then you want to go into circles now. Right? What we're going to do with these circles, we are actually going to develop the equation. Let's say I gave you a circle. Right? Let the circle center be AB. And let a point on the circle be XY. Right? Let's see if we can develop an equation of the circle. Of course, the distance from the center to P is R. Right? We are going to try to develop an equation here. Are you doing this all good? Oh. Only headphones and listen to music. Right? So the length of the line R is equal to what? The length of the line R is equal to what? I can use the first formula, right? I can use the first formula. So that'll be the square root of x minus a squared plus y minus b squared. That's okay? This is your first equation, right? Square both sides. X minus a squared plus y minus b squared is equal to r squared. Right? So this is your first equation of the line. Your first equation of the line with center AB and radius equal to R.
Wait, what size is it?
Expand itself from a expanded from a Right, let's call the equation one. Expand equation one and let's see what you get. Finish? When you expand, what you got? When you expand it out? So when you expand this out, you'll end up with x squared minus 2ax plus a squared plus y squared minus 2by plus b squared is equal to r squared. Right? So you'll end up with x squared plus y squared, 2ax minus 2by plus a squared plus b squared minus r squared equal to 0. Right? So to make it look a little more familiar, we could let g equal to minus 2a, sorry, f. We could let g equal to minus 2b, and we could let c equal to a squared plus b squared minus r squared. So the formula might look something like this: x squared plus y squared plus 2g plus 2fx plus 2gy plus c is 0. Right? This is the next equation, right? There's called one standard and one general, right? But these are the two equations of the circle. Okay? So you have to be able from this now to find the center and the radius. Right? Let's see if we can find a quick revision. Let's see if we can find the center and radius here, right? We have a minute. See if we can find the center and the radius there. Okay. Okay. Right? What we want to find the center and the radius here. Huh? No, I just write in something. Right, so before working this out, the first thing you have to do is what? What's the first thing I do? Coefficient should be 1, right? So the first thing you do is divide by 3. So you'll get x squared plus y squared minus 2x plus 3y minus 4 is 0. Right? When you divide everything by 3, now you can read off things, right? So you could say now that you can compare this to this, and you can say that 2f is equal to minus 2, so f is minus 1. Right? Then you could compare here, you could compare 2g to this, so you could say that 2g is 3, positive 3, right? So g is equal to 3 and 2. Okay? So therefore the center is what? The center is always minus f minus g. So that's 1 minus 3 and 2. Okay? And then the radius is the square root of x squared. The square root of x squared. So that's minus 1 squared plus g squared minus c. C was minus 4, so I put in plus 4 here. Make it help more then. What is one? Put the calculator on, please. But not too much trouble. So I get it. Huh? 2.69 after the square root. So the radius is 2.69. Okay. All right. Yeah. So always remember, right? Always remember that we are equating the form x squared plus y squared, right? So that's divided out. So although you're seeing a 3 there, it can still be a circle. All right. Let's try the other way now. Let's try the other way around. Find the equation of a circle, going the other way around, right? Find the equation of a circle. Given that the diameter of the circle. Given that the diameter of the circle. Has endpoints. Given that the diameter of the circle has endpoints. A is 5,9. A is 5,9 and B is minus 1,1. Having back to front bottom on the way. Right? So they want the equation of this circle. Give one that, right? So to get the equation of this circle, based on what we know, what do we need? We need the center and the radius, right? Remember they call this the standard form and this is the general form, right? So let's get it in the standard form and then specify, right? So I need the center and the radius, right? How will I get the center there? Yeah, get the comment. No. What did you do? Sorry there. So what do you need to get? Keshav, what do you need to get? You need to get the midpoint and then the length of the line, right? Go ahead. Find that fast. Take the time, find the midpoint. Find the point at the mid. Find the midpoint and then find the radius, right? I don't think it'll be. Yes. Yeah, it's nearly one too far. But I'll do it. Oops. You just want to go down. Right? So while you're doing that, right, here's what I'm going to do next. I'm gonna give it 3 points on the circle and you gotta come up with the equation of the circle. But none of the points, right, come in diameter. So I'm gonna give it 3 points, random points in a circle. And we're gonna try to get the equation of the circle. Think about it in the meantime. Alright, so we're gonna try and get the midpoint. So the midpoint is x2 plus x1 on 2, y2, y1 on 2. 4 on 2 is 2, 10 on 2 is 5. Right? So we are the midpoint. At the center. At the center, right? Harry? It's the center. Like a normal allocation. Allocation, like position. Anyway, I using that. Right? And then we need to get the length of the line, the radius, right? So going from the center to the point, to the radius will be 2 minus 1 all squared plus 5 minus 1, right? Square root of 3 squared plus 4 squared, which is 5. So the equation of the circle, this is the standard form, of course, right? This is the standard form. Standard form of the circle is x minus the center squared plus y minus the y value squared equal to the radius squared. Equal to the radius squared. Right? And if you want to get a general form, what to do? Expand it out. Right? But since you're practicing, do that now. Find the general form one time. Right? Because I want to jump into that next question now. Give you 3 points on this circle. Double arm. Look at that. Expand out some way again after this. Tell me what you got. Oh, you do it already? Well, where you get minus 4x minus 10y plus. Nice. Okay, so that's the equation of the circle, right? But of course, you cannot, well, I don't want to say not one things are simple because it came before, simple things like that, right? But what you're really going to see, you might see if you see a circle, right? We'll come to the other forms just now, right? But here I gave you 2 points that make up the diameter. Suppose I gave you 3 other points. How are you going to come up with the circle earlier? What are you going to do? No, non-aligned. So you're going to get this. I'm going to give you a circle. And I'm going to give you 3 points. A and B, they don't make a diameter. Neither does C. What you going to do? Huh? Leave it out. What you will do? So you want to get, of course, center and radius, right? Or if you get center, you're good to go, right? If you get the center, it's easy to get the radius. You have 2 options. Anybody can see? One of the options. I want to remember this. An equation is always of the form x squared y squared plus 2fx 2gy plus c equals to 0. How many unknowns you have there? 3 unknowns, right? So if you have 3 unknowns, how many equations you need to solve? 3. Is it possible to get 3 equations if you have 3 points? Yeah. So if you have 3 points here, if you have one here, and one here, right? Can we put the 3 points in here and then solve them simultaneously? Yes. That's option 1. Right? So option 1 is to take the points, the x and y values in and put them in here 3 times. And then solve same equation, but you put in the x and y value 3 times. That's method 1. Right? Method 2, a little bit longer. Right? But here's what you can do. You can find AB. Right? People who do TD might know this. You find AB and then you find BC. right? And then when you find the equation A, B, and the equation A, C, right? Well, you don't need the equation actually. What you need to get is the perpendicular bisector of AB. So find the perpendicular bisector of AB. And then find the perpendicular bisector BC. Right, my diagram is looking so 100 there, but once you have those two equations, you solve them simultaneously and you'll get the center. And then from there, you get the radius. That's okay? So you have two methods. You could choose any method you want. Right? Method 1, method 2. Okay? Well, I didn't show it too good, right? But you'll follow what to do. You get the equation of the perpendicular bisector of AB. Equation of the perpendicular bisector BC. Solve them simultaneously. Right? That'll give it the center. So method 1, I like method 1. Substitute the 3 points in the general form. Right? And then 2, solve the 3 equations simultaneously to obtain F, G, C. Right? That's method 1. Method 2, get the equation of the perpendicular bisector of AB. Get the equation of the perpendicular bisector of BC. And then 3, solve simultaneously to obtain center. All right. So we're going to try one and you can choose any method you want. Right? Any method you want, you can choose, but I will be choosing the method 1. Yeah, making it both method. I think you could either somewhere. Either. You can do both methods. I like that some more. That's good. Then I'm up for I love it. All right. Let me let you start it up now. Right? Right, we are doing both methods earlier. Hopefully we get the same values, right? Hopefully we get the same equation, sorry. A is 2, 3, B is 5, 6, And C is the H3. Right, make sure I give you points that will work out, right? Right, with method, right method, one and. Sorry, two 3 points in general for. Oh, find the equation, and it could when you of bisector, maybe. Right? Can I do method one now? No. So let's take a look at method one, right? So method one allows us to substitute things, right? Method one allows us to substitute the values and see what we get. Right, taking this and putting it here, I just mind, right? Right, so that would be what? That would be 2 squared plus 3 squared, plus 2fx plus 2gy plus let's go this again. C that's equal to 0, right? So this is 4 plus 9, that's 13. Plus 4f plus 6g plus c is 0. So your first equation is 2f plus 6g plus c is minus 13. What? 4f. How about? Take off your headphones and I said 4f. Look how 4f here. Take off your headphones. Right? So that is equation 1. Equation 2 now, I'm going to substitute 5, 6. So when I substitute 5, 6, I'll get 5 squared plus 6 squared plus 2f by 5 plus 2g by 6 plus c is 0. Right? This is 25 plus 36. That's what, 61? Yeah? So this is 61 plus 10f plus 12g plus c is 0. Right? Just make it look nice. So you'll get 10f plus 12g plus c is minus 61. Right? I hope you all see here that we could just subtract and get rid of c, eh? Y'all see that? Once you get rid of c, you're good to go, you know. Right? Once you get rid of c, you get f and g and you can solve. Right? Whenever you solve an equation, right? We'll never tell all this, right? But whenever you solve an equation with 3 variables, you have to get rid of one of the variables. So you'll end up with 2. Right? Probably the wrong class. I'm telling next class. You have 2 probably. 8 squared plus 3 squared plus 2f by 8 plus 2g by 3 plus c is equal to 0. So when you work this out, what do you get here? What's this? 9 and 64? Huh? 64 and 9 is how much? 73. So that'll be 73 plus 16f plus 6g plus c is 0. So that'll be 16f plus 6g plus c is 73 minus.
No, that's the opposite.
Everybody okay with us? So now we have to get rid of c. Right? Now all we have to do is get rid of c and we're done. And let's even let's here to the guide you through this one, right? Right. So all I want to do is I want to get rid of c, right? So I'm going to take equation 2 and minus equation 1. I'm going to take equation 3 and minus equation 1. That will help me get rid of c. Or Keshav, we can make c the subject of the formula and then substitute here and here. Anyone you want. But instead, I am just minusing these 2 equations. Right? I'm minusing these 2, so I'll get rid of c. I'm minusing these 2, so I'll get rid of c. And then solve the remaining simultaneous. Right? Whenever you're solving simultaneous, you always try to get rid of the extra variable. So if you have 3 variables, you gotta get rid of the 3rd variable, then the 2nd variable. Right? If it's 2, you get rid of one of them and then start with the next one. If it's 4, one at a time. Okay? I'll give you a 4 just now. So equation 2 minus equation 2 minus equation 1. 10 minus 4, that's 6. 12 minus 6, that's 6. C minus C is 0. Minus 61 minus 13 is how much? Minus 48. Right? We can make it look a little nicer. We can divide by 6. Right? When I divide this by 6 is what? Minus how much? Right, sorry. What is divided by 6 again? 8 minus 8. Right? Now equation 3 minus equation 1. Right? So that'll be 16 minus 4, that's 12. 6G minus, ooh, that worked out real nice. I didn't see that before. 6G minus 6G is 0. Plus 0 is equal to minus 73 minus 13 is. What's that? That's 60, right? That worked out real nice. Yeah, sorry, minus 60. So minus 60 on 12 is minus 5. That worked out real good. Now, take it from my book. That's why it worked out so good. Right? F is minus 5. So therefore, G is how much? Right? G is minus 3. So you're good to go. Right? Now we gotta go back and find C. Yeah? Gotta go back and find C. Let's say with myself. You love beams, right? Last one is C. So I'm going to substitute F is equal to minus 5. G is equal to minus 3 in equation 1, right? Those numbers looking like the smallest. You know, I didn't see that 6G, that looked out real nice. But, well, yeah, right? If it got a value here in terms of G, you're just solving these two simultaneous. Okay? This one just worked out real nice. Real nice. That's way easy, right? So that'll be 4 by minus 5 plus 6 by minus 3 plus C is equal to minus 13. Any questions online there? Ooh, look one. That's multiple choice. That's the multiple choice. Yeah. All right, nice. Chelsea, you're okay? Yeah. So, and then you solve for C, right? This is minus 38. So C is positive 38 minus 13, which is 25. Just doing what you want inside here. Right? So you end up with what? You will end up with the equation, the standard form as x squared. Sorry, the general form as x squared plus y squared. I'm using this form, right? 2fx plus 2gy plus c is 0. So you're going to get x squared plus y squared. F is minus 5. So that's minus 10x. G is minus 3 minus 6y plus c plus 25. That is the equation of the line. Okay then? Huh? 3 marks? Yeah, 3 marks. 1, 1, 1. What is that? 1, 1. Finish. Not fast. I got 1 mark. 8 or 9 years. Right? That's method 1. Yes, sir. And in the city center is minus F minus 3.
Okay.
So you can write the centers as what? 5, 3. Ayan, talk to me. Right? So you could have also written x minus 5 all squared plus 8. Right? You okay with that? Well, we're not done yet. Do method 2. Huh? Yeah. No, I just try to mix it. Right? The general thing to do is make C the subject in equation 1 and sub. Right? That's the general thing to do. Right? I just choose this because these values smaller. So I won't have too much negative sign. Right? Oh yeah, do method 2. Method 2 now. So maybe I volunteer to come on the board and do it. Don't the black one blue. Move. Right? Find the perpendicular bisector of AB, perpendicular bisector of PC. and work it out, please. I know it's long, but. All right, so method 2, we had to get the perpendicular bisector, right? So the first thing we need is the midpoint and the gradient of this line. I'm gonna get the gradient of AB first, right? The gradient of AB will be 6 minus 3 over 5 minus 2. So the gradient is 1. MLP? MLP? All right. Right, so the gradient of this line is 1. So the gradient of this line is minus 1. That's okay? So the gradient of the perpendicular line is minus 1. All right? Everybody okay with that? the gradient of the perpendicular line is -1. All we need now is the midpoint. The midpoint will be 5 plus 2, which is 7 on 2. 6 plus 3, which is 9 on 2. Are you okay with that? That's the midpoint. Now we have to get the right now we have to get the equation. Right, equation 1, I call in this line 1, right? And I call in this line 2. So the equation of line 1, y is equal to mx plus c. C is y minus mx, right? So y is 9 on 2. Gradient of the perpendicular line is -1. And x is 7 on 2. So that's 9 on 2 plus 7 on 2. 16 on 2, that's 8. So the equation is y is minus x plus 8. Anybody got that? Equation 1. This line here. Line 1. Right? Malia. Yeah, you'll get the same thing. And it'll look nice less like this. Good. Have a see. Oh yeah, we do the next line first and then it's all simultaneously. Find it on two something or by we usually or what is the by one minus?
Let's go back to that.
That is -5 and change on -3. Well, that's what my do that when I'm going to change. Excuse me, is yours? Oh yeah, Paul, yeah, line 2 and then south simultaneously. Right? I think I look at Cartesian. I don't know. That next term, that's not really time. We did Cartesian in Adma. Sorry, we did pharmacy equation of a surface. Adma. We will do that next term. Yes. Now we focus on module 3 and then we do our review. Two samples to put on. You got to do SBA already. I'm gonna send you 2 samples. I'll send you 2 or 3 samples, right? Let's take a look at it and see. Yeah, but I will send it and I to now. I'll send 2. I don't have 3. I'll send 2 different ones that you can try. You all done? Oh yeah. It's not done. I don't want anyone to have to right, line 2 now. Equation of line 2. Right? First thing we need to get is the right. Let's get the gradient. Let's get the gradient of BC. So that would be 6 minus 3. That's 3. 5 minus 8. That's minus 3. Right? So that gradient is minus 1. So the gradient here is plus 1. Anybody get that? 6 minus 3 is 5 minus 8 here. So I got the gradient to be that, and the midpoint now. The midpoint will be 5 plus 8 is 13 on 2. And 6 plus 3 is 9 on 2. So I know the gradient, and I'm going to try to find C. C is y minus mx. So that's 9 on 2. 9 on 2 minus positive 1 by 13 on 2. 9 minus 13 is minus 4. So I got minus 2. So my next equation is y is equal to x plus 2. That's equation 2. Anybody get up? Y is x plus 2? Sorry, minus 2. Minus 2. Thanks. So if I substitute equation 1 in equation 2, I'll get x minus 2 is minus x plus 8. So I'll get 2x is 10, I'll get x is 5. So the center is 5. Correct? We are correct. And y is equal to 3. Yep, 3. So therefore, our center is 5, 3. And we can go right ahead and find the radius. That's okay? Right? So I found the center 5, 3. That's the same values we have here, right? Because remember the center is minus f minus g, which is 5, 3. Right? And then you have to go and find the radius. The radius is the square root of any point you want you can use, right? Of the center x minus 2 squared plus y minus 3 squared. Right? So I got, I'm feeling wrong. Right? 5 minus 5, that's 0. 3. I get the radius of 3. Huh? 5 minus 2, 3 minus 3. Right? So I got the radius to be 3. So the equation is x minus 5 squared, y minus 3 squared is 3 squared. If you work this out, you'll get x squared plus y squared minus 10x minus 6y 25, 9 plus 25. Same thing? Yep, same thing. So we're good to go. Any question? Which one is here? Method 1 or method 2? So look how short method 2 was. Yeah, I find method 1. How should we go? How do we get what? How do we get what? Here, what?
Just here.
Here.
Let's see everything.
Are you okay with us? Answer me, like you want to complete. What point I use? I just use the center and this. Anyone you choose will give you the same thing, right? You could choose anyone to find the radius, and anyone, it don't matter. They'll give you the same length. Center is 5, 3. So 5 minus 2 and 3 minus 3. No. I use length of the line formula. Right? I use the length of the line formula to find the radius. And then when I get the radius, I bring it in here. Then I use x minus a squared plus y minus b. Any questions online? Online, any questions? Yeah, A, B, and C on the circumference circle. Right? A, B, and C are the circumference, but none of them, when connected, form a diameter. You all okay with that? Are you okay with us? Online? Like online face out there. The next thing I got to do in circle is something new. And if I do it now, you won't remember it's in January. Can that be up? Alright? So let me just do one question. Huh? Passy, what about it? I like that. I like it. Wow. Alright, last thing before we wrap up. There's some component that you have to remember. You gotta remember how to get the equation of tangent. Yeah? Tell me, how you get the equation of tangent? If Darian answer, we stop him. How we getting the equation of tangent?
Wait,
How we getting this equation here? So I want to get these two equations.
wait, you give it many points of line.
I gave it, okay, yeah. So are we good? I given it this and I given it this.
Alright, yeah. What nobody asked. But she said that.
Right.
Yeah, yeah, find.
Make sure I get it right, yeah, otherwise.
Yeah, find the gradient, right?
Find the gradient of what? You don't start by there.
What?
Find the gradient of what?
Radius.
Right, find the gradient of the radius, right?
You got it, negative.
Right. So here perpendicular.
Yeah.
Right.
Right, and then after that, it will, you put some. The points and the circumference. To find the.
And what?
Huh?
Which point you using here?
What then the first, the
P, okay. And what else?
ingredients,
Okay. So and down and put it into what?
the equation.
Or this which circle? The equation of the line, right? And how you get the equation of the normal?
You got this, is the radius.
The equation of the radius. Alright? Right, take a small note. Wait, take a small note down, take a small note down. Catch that part and take a small notes. Right, now we got Daria note.
Yeah.
Chica, but we know what we know, right? Oh yeah, catch that diagram there and then I'm gonna give you one small note and be done. I have this also. I have to get on the right? So to obtain the tangent, to a circle. To obtain the tangent of a circle at a point P. Step one. Step one, use the point P and the center to find the gradient. Use the point P and the center to find the gradient of the radius. Right, so find the gradient of the radius. Step two, gradient of tangent. Gradient of tangent is equal to -1 over the gradient of the radius. Gradient of tangent is -1 over gradient of the radius. And then step three, use the equation of the lines to find the y-intercept. Use the equation of the line to find the y-intercept. That's step three. Right? Use the equation of the line to find the equation to find C, y-intercept. And last thing, note that the gradient of the normal. Note that the gradient of the normal is the same as the gradient tangent. The gradient of the normal is the same as the gradient of the radius. Sorry about that.
Is it done?
I know, I'm sorry. I'm sorry.
So we didn't.
Gradient of the normal is equal to the gradient of the radius. All right.